to talk about building an internal developer platform for the multi-cloud world. And I don't want to get into a discussion for why, this is a good idea. I mean, usually if you can avoid multi-cloud, avoid multi-cloud. But the reality in the modern enterprise is that this is not possible. This can be because, you have an acquisition, you're sufficiently large. So this is, you're a bank, you have a mandate, you have to do this. It is legislation. Very often merger and acquisitions that come in and have to be, and the team does not want to change their infrastructure, so now you have to support too. So this is a problem that we're always confronted with and if you are, if you are above 200, 300, 400 developers, it's probably a good idea to design your platform to make sure it's ready for multi-cloud, because you never know what funny idea life throws at you, and at that point you want to be prepared. And actually, if you follow, the recent design patterns with layered abstractions, then you get this by design. So why not take advantage of this? And from an architectural perspective, we don't want to architect ourselves into a specific corner. So in this talk, we're going to speak about how we have actually created the reference architecture, and to be more precise, how our friends at McKinsey's platform team have done this, and we've collaborated with them closely. What are the problems that we actually aim to solve, and for what persona group? What are the design principles? And then we're going to actually look at that design. And in the end, I'm happy to take whatever question you may have. So we've been talking about internal developer platforms for a long time now. I have at least used this term 80 times a day for the last 5 years. But for a long time, we've been a little vague what we actually mean by this. But this is not the case anymore. These reference architectures are even packaged as code now. You can literally have one running on your cloud or on-prem setup 15 minutes from now. In general, the architecture landscape and the best practices in platform engineering are way more advanced than anybody thinks. I still see people, starting with long sessions and months of work on, hey, how should we do this? And where should we start? In my observation, at least, this is an established thing now. We are beyond the early adopter. We are getting into the majority already, and I think it is worthwhile using those things that already exist. Now, we have an interesting situation that we probably talk to more platform engineering teams than, I would probably say anybody else in the world. We have around 10,000 leads roughly every month, and pretty much, let's say, the majority of enterprises that have a mandate for platform engineering at some point evaluate our stuff. And so we get to talk to them, which is a big privilege. And that means I myself am probably speaking to 200-300 organizations every year. And after a while, we saw a certain pattern in the tools that they used, and we work together with McKinsey. The platform team at McKinsey also sees a whole bunch of stuff, and we've had a closer collaboration with them, and then we started to build these reference architectures, and now we're actually going into the multi-cloud area. Although from day one, those reference architectures have been designed for multi, just because of this approach of dynamic configuration management. So the thing that we're actually solving for as we're building these platforms, in general, if we are working on platform engineering, is a multifaceted problem. It is death by 1,000 paper cuts, and that for me means that the problem is felt differently by persona, and our common enemy, the thing that we're all fighting, if you want, is the disjointed toolchain. The disjointed toolchain, if you want to understand why you're getting up in the morning, get yourself a white piece of paper and write disjointed toolchain and a skull on it, and then you know what you're fighting against every day. And the disjointed toolchain, I think, has a significantly higher negative impact than we believe. And again, it is perceived differently by persona. For a CIO, looking at it from the ivory tower, it essentially materializes in, we're really slow. For a finance team, it materializes in, I have these enormous amount of costs, but I don't really know what app has created what cost. I can't attribute, it just keeps growing. For the operation teams, it is the question of why on earth are we drowning in tickets? Why are we getting those repetitive requests? Why am I spending my days reviewing Terraform files? For the application developers, it is, I'm slow, I'm being stuck. There's constantly stuff shifted left, and I don't want to work with the AWS console. And for architects, it's how can we make sure labels and annotations make it their way into this, into all of these different components? How do we make sure we're enforcing certain standards? How do we make sure we design this efficiently? So there is a magnitude of different problems. And the answer to that is, if you do it well in internal developer platform, and again, the value is perceived differently. And I'm saying this because the value is perceived differently, which also means you need to cater to a whole bunch of different people. And so that means the things that feel obvious often aren't obvious. So for the CIO, it's about slashing lead time. For the operation team, it's driving automation. For the app dev team, it's about self-service and speed. And for the architects, it's about driving standardization. But I think it's important to keep this in mind during the architectural process, and it's important to keep this in mind also as you're prioritizing what to work on. There are certain things, for instance, you should just do because it looks nice. Why this is a problem prominently shows the example of Netflix. And there is an interesting observation that I have. If you don't have results, and results means adoption by your developers, because in the end, developers are going to vote with their feet, you have a very high likelihood of failing in the next 12 months. And I like to use the example of Netflix because Netflix is perceived as the angel guardian of platform engineering, the people that do everything right. And I like to encourage you to watch the 22 talk at PlatformCon by Brian Leatham, one of their senior engineers, who said like, hey, we've built this amazing thing. It looks fantastic. It's a portal you can click. This is amazing. And then a year later at PlatformCon 2023, he says the view and assess experience provides value, but on its own is not compelling enough to pull users in away from existing habits and routines. That's a very important learning here. It means that if your developers don't use this, you will not survive. So, and this already gives us a hint on how good interface design, for instance, looks. So make sure you really understand what's out there and understand your user, but also understand the political landscape that you're working against. So for instance, this here shows us, and I'll show you more data in a second, that we shouldn't design these systems primarily for user interfaces, because this is usually not being adopted by developers. But obviously, C-level needs to see a user interface because then it's easier for them to digest. And me saying this will make you go crazy because it feels like, how on earth is this all fitting together? But that actually shows you that it's a non-trivial sequencing exercise here. You need to essentially show fancy dashboards to the one persona, knowing that the persona that will keep you in the driver's seat long-term, the developer, actually needs a different interface. And this already helps us to understand how are we supposed to actually design these systems at scale. Now, how do you get from a disjointed toolchain to an internal developer platform? Well, the first thing is you will just have to acknowledge that you have to work with what's there. You will not be able to retrofit everything, and you will not be able to actually deal with it all. And that means you have to assume a brownfield setup. You have to assume you are confronted with the CI pipelines that you have, keep them as they are. There are registries, there's secrets management, all of this is there. But for every good platform, and I know that people disagree with me, but I don't really care because this is genuinely what I believe in. For every good platform, you need to do three things. You need to abstract. There is no platform engineering without abstraction. Loaded term, many people, I'll get funny comments on social media, but if you do not abstract and you move your developers an abstraction layer higher, you will not build a good platform, and you will not be able to build a platform for the multi-cloud estate, because multi-cloud experience, platform experience, is not possible without an additional abstraction layer. We are going to learn more about this in a second. Then second, you need to standardize. You have to have a standardizing function. Multi-cloud and exchangeability and streamlining and keeping your ops budget under control is not possible if you have a one-on-one relationship between workload and resource configuration. It just doesn't work. You need to get into a many-to-one. Many workloads share the same type of resource configuration, and we are completely eliminating drift between those configurations. Very important. And then third, you have to visualize. And yes, you have to visualize, not because it makes sense, right? In a perfect world, the platform would be code, but there are actors and persona groups that need a user interface. And those could be some funny dashboards. Nobody will ever look at them long term. But there needs to be something that managers look at and say, oh, a platform. This is why I'm giving you budget. So that's why I think you need to visualize as well. Now, a reference architecture is a design pattern. It's also packaged as code. So if you go to, we can do this, reference this here, then you will have pre-packaged reference architectures, everything included. You can just point this at your, you fork the repository, you point this at your cloud accounts or wherever, and then it will set itself up. This is published for Amazon, this is published for Google, is not yet published for Azure and OpenShift, although all of this is supported, but this will be coming. And so this is what a reference architecture is. Now, we've applied a certain amount of design principles to this when we designed this. The first I've already mentioned, it's golden paths over cages. It's fine to abstract, you'll have to abstract, but it's not a strict abstraction wherever possible. If you're a security heavy environment, the developer will not be able to say how the database is configured in production. I get that. But wherever possible, that you should nudge the developer to stay on the golden path because they're getting certain advantages, but you should not cage them in. Golden paths over cages. Second thing is, we've mentioned this before, brownfield compatibility. That's pretty obvious. Second, treat the platform as a product. I am giving you an idea how to start the design journey, but that's obviously your platform. And our mission statement is serving platform engineers. So I'm always only providing the tools and the framework if you want, but you'll have to localize that to your own thing. And the thing here is everything is code. I believe that your platform should be completely packaged as code. This is very important because it makes it testable, disaster recovery. There is no reason why, this is a software product. Why should this product not be as code? You should test it. You should have the same product design principles. And if you are larger scale, you might want to have certain versions of your product. And then you want to version as code. I have just started working on a very large scale setup where they have a global platform and then they have local platforms for the country units. And that makes total sense. You want to make sure that everything is code. The last thing here that is hidden for whatever reason, I know, here we go, it's a fancy animation, is that we are in a business of 80-20. Platform engineering is a business of 80-20. Do not assume ever that you're going to have your entire estate on the platform. It's not going to happen. There are different, preferences in your customer base, and some people will say, I've been essentially leaving my mother's womb with Terraform by writing Terraform scripts, and I am going to go into the grave with Terraform. I do not want to have any other layer. And you will not be able to convince them, and you shouldn't fight that fight. Just let them go. Let them do this. It doesn't matter. They should do this. Platform engineering is about, again, 80-20. And I don't know a single platform, even the very advanced ones, Mercado Libre in Brazil, Bull.com, none of them have 100% coverage. And that also means do not focus on everything at once. You should build your platform against a lowest common denominator. In the vast majority of cases, this is containerized Kubernetes and then whatever other resource. But for compute, you should essentially settle on one compute standard and then support all other resources, database, file storage, rather than trying to nail everything at once. There is a reason why there is no provider who's able to do this. And the reason is it's incredibly complex to orchestrate this. If there's no provider able to do this, you are not going to be able to do this either. That's very likely the case. At least you're not going to be able to do this at a high quality that will keep developers happy. All right, so here is such a reference architecture for the multi-cloud world. And this is completely overwhelming and a lot of different logos. And I'm going to dissect this bit by bit here. This is a multi-cloud setup on Amazon and Google, but you can exchange essentially every logo that you see here. There's actually a fantastic overview about what tools to use on platformengineering.com/tooling. Yeah, that's platform engineering. We can send it later. /tooling, and that's the same design. Yeah, here we go, platform tooling. And that's the same design if it loads, and it will allow you to essentially understand where I'm coming from and what other tools there are that you should evaluate. Now, what we're seeing here are essentially 5 planes. Those planes are designed in planes, so it's at least a little easier for you to digest. We have the developer control plane here on the upper left-hand side. The developer control plane is where developers and all the users interact with the platform. And I am a big fan of, we're going to cover this in just a second, leaving interface choice for your users. So developer control plane has a user interface. As an example here, we're using Backstage. There may be like a quick word of warning, also evaluate other stuff. There is Cortex, for instance. I'm doing a webinar with their CEO tomorrow. I think that's a fantastic tool, significantly lower cost of ownership. Atlassian has one with Compass. So make sure you look at those as well, because it's maybe cheaper than building this with a framework. So yeah, I encourage you to check these options out. Then we have version control. Version control, it's very important that we now already get a first glance at the abstraction level. We differentiate application source code that does not contain any environment-specific configuration. In this world, the application source code contains the workload source code, and it contains a workload specification. That's an abstract description of the architecture, if you want. Is very important for multi-cloud design. I'm going to cover this in just a second. And then the second element, the platform source code, those are your rules. How are we supposed to configure staging, Postgres resources and staging? What are the automations? That's all in the platform source code. So these things are differentiated, very important. You'll have different rules for different multi-cloud estates, cloud estates, but your workload should be able to run wherever and regardless. And that's also important to keep the developer experience absolutely consistent and constant across any cloud. Now, Then we have the integration and delivery plane, because we have to take this and now actually turn this into something. CI to build the image. We have the registry here to store the image. Again, swap whatever logo you want. You have a platform orchestrator. Many people look at this and say, what's a platform orchestrator? But I think we're beyond that. It's in the developer documentation at Microsoft. It's on the ThoughtWorks radar. There are several options out there. Platform orchestration is an absolutely vital component. And yes, you can, one can probably also throw this together with scripts, but it's non-trivial and very expensive to build. You have CD to actually deploy this. And then here you have the different estates. We have a Amazon estate here, Google estate here, gateway in between. We have the monitoring and logging plane, between you and me. You'd probably not use Amazon CloudWatch. That would be Datadog or whatever. And then you have security plane, secrets management with HashiCorp Vault or whatever. And also policy planes, probably OPA. Those would go into the security plane. So here we go. That's our design for a platform. It doesn't tell you much how the inner workings work. So let's jump into this right away. Now, the first thing that I want to say is leave interface choice. Give them the option to use a portal or to use code or to use an API or a CLI or Terraform, whatever. Let the user vote with their feet. The user is going to vote, and I can already tell you how they're going to vote because I have actually taken this funny slide literally 10 minutes ago from an internal QBR review with a customer. And so this customer is a customer that I cannot name. Financial services started building their platform in March or April this year, has 80% of their production estate on this. And the thing is, over 3,000 active resources. So pretty good usage. But that's, forget it, doesn't matter. They ran 15,976 lifetime deployments. And so that lifetime means that they're on this system for 2-3 months after it's fully built out and scaled. And 98.8% of all of those deployments are code-based. 98.8% of all of the deployments, the developers do not leave the Visual Studio Code or whatever they're using. And when I started working with this team, somewhere in the United States, and they were telling me about, we are going to build a user interface, developers are going to click, and I said, yeah, that's fine. Let's put a fancy UI on top. That's good. But the reality is developers are going to use code because they don't like a break-in interface. Developers hate to change behavior. Developers, and we all hate to change developers. They're not so special in that regard. And so they are going to stay where they want to stay. They don't want to break an experience. So I highly encourage you, think code first. And code first does not mean make it complex. Code first, you can be beautifully simple in code, but just think code first. And don't assume UI-heavy systems see a lot of adoption. And I think this data proves it well. These developers here have the choice. They could use whatever they're using code. So anyhow, so what's the design approach to get this done? And the design approach is the approach of layered abstractions. And now you will have to drink a cold glass of water and concentrate a little bit because this is non-trivial, but important to understand. So essentially, the key problem here, and I'm going to zoom in a little bit, is that the infrastructure as code layer gives you an incredible amount of configuration options. Sorry, 1 second. Sorry, I think I stopped sharing, for which I'm very sorry. Now we're back again. Yeah, I hope so. Okay, so sorry about that. So here we have so consider this all your config options for an infrastructure as code. Like think of all the options you could configure an Azure database, an AKS, and blob storage, and then the same thing for Amazon and Google and OpenShift and all of these beautiful systems. Now, enormous amount of variability. Why? Well, because the the infrastructure providers have to cover every possible edge case. Only because infrastructure providers have to cover every potential edge case doesn't mean you have to do this. Also doesn't mean that your application architecture benefits remotely from the amount of options. Now, a good question to ask yourself is, I mean, I bet if I send you back into your day life and you are supposed to figure out how many different configuration options do you have internally to configure Azure DB, you're probably going to come back with 300-400. But if we really take a second and think about it, there are no 300 to 400 materially different ways to configure any given resource. That just doesn't exist. It's not necessary. It's not efficient. The more complexity you have, the more variance in configuration options you have in your estate, the harder it is to maintain, the more costly it is to run, the more likely it is you have outages and security concerns, and the harder it is for the developer to consume. So what we're essentially doing is that we are building and we are reducing the option pool. And you want to reduce the option pool to by thinking the following ways. What type of resources do you need? So let's say Postgres, I mean, no brainer, you'll need a Postgres. Okay, so how many materially different ways of configuring Postgres in staging do we need? This needs to actually vary by environment. Your production estate will look different from staging, will look different from dev, just because of cost and other security concerns. So you'll end up with, let's say, 4 or 5 ways of configuring, probably 2-3 different ways of configuring Postgres in staging. Okay, so now you take this and you do this for the providers, the hosting providers that you need to support. Let's say Azure and Amazon, let's say Amazon on Google, whatever. Now this actually gets you to a configuration option pool. Now your design system has to say every single workload that is needs Postgres in staging has to use by default those recipes, and the drift between their status quo and that recipe at any given time in the lifetime of the application and workload has to be absolutely zero. Absolutely zero. Not one line of Terraform can be different between the actual running configuration system and the recipe. How is this possible? By reinforcing those configurations with every single deployment. That's the design principle that is very, 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 very powerful and helpful. Now, in order for that to happen, we have to now actually pull apart what the developers want, so the developers' intent. We have to essentially get the context, because we need to know that this is going to an environment type staging, and then we need the recipes. So let's say we have the recipes, write them in whatever you want, write them in Terraform, write them in Crossplane, write them in you, whatever. And then once we have that, we need to introduce the higher level of abstraction, because we need to know in abstract terms what is the relationship between the workload and the dependent resources. And this is where we're introducing this layer. And this layer is called a workload specification. We are specifying how the workload is actually the environment agnostic way the workload is configured. So if this here is a workload, right, of whatever name, then we say, okay, this needs a Postgres, this needs a compute, this needs a file storage, this needs a DNS. If I want to deploy my workload into production, then it still needs Postgres, it still needs compute, it still needs file storage, it still needs DNS, right? Because this is like an abstract information that's consistent wherever. At this point, it doesn't matter whether it's running in Azure or in Amazon, whatever. So now we need to be able to dynamically pick with every single deployment, because we want to completely eliminate drift. We have to pick the right recipe Then we have to execute the recipe to enforce zero drift between recipe and running system. That is actually the design principle here. If we do this, we end up in a world where developers can, by default, stay up here, unless your RBAC is set in a way where you want to allow them to touch the recipes. You can do this. This will lead to you reducing the amount of standardization. But this is the design principle here. So, and that also means that if we differentiate this a little bit, now let me zoom out again. Here, we now have the following layer of abstraction. We have our workloads with the resource dependencies. So that's the service code, then this is a workload specification. And this is what application developers, that's the golden path. That's by default where we want to keep developers. Don't enforce it, let them allow to see the recipes, let them allow to see Terraform, not against this, allow them to go off the golden path if they want, but then pull the guarantees away, don't give them a service level on this. Then we have cross-shared standard governing templates by the platform team. Those are the recipes, essentially an infrastructure as code library that we continuously enforce. And then we have our running infrastructure components. There are details because in the end, you already have production systems now. You'll not be able to go into the enterprise and say, hey, funny new idea, we're going to refactor everything. That's not going to fly. For that, there are ways to actually compensate this. So you can probably start with all the new stuff. And then the next time you do a refactoring of your databases, you will put them on the latest standards. There's a gradual movement towards this model, but this is the model where you ultimately want to end up. Okay, so now let's actually take another example. Now I want to also deploy my workload to production, but this time it should be Amazon. So this layer stays the same. Now we're picking the right recipe based on the context. And now we're actually sending everything and putting the different config options of Amazon into the right state. This procedure, the procedure of resolving an abstract request against a set of rules based on a context, this procedure is called platform orchestration. The procedure of taking an abstract request and based on the context, resolving, picking the right rules and executing them. This is called platform orchestration. And you mark my words, this is going to be the design principle that the cloud native world everywhere is going to apply in 5 years. There are still people disagreeing, but I am 100% convinced that this is going to be the case. Now, the orchestration procedure here is first, fetch the workload and the deployment metadata because we need to know the context. Identify the right resource dependencies. Okay, this needs a Postgres, compute, file storage, and DNS. Match the resource recipes by that context by essentially picking the right one, sorting lists based on the metadata, and then update and generate the infrastructure to keep the drift between the recipe and the running resource to absolutely zero. Absolutely zero. Now, this is possible if you, this abstraction level, so this here, my workload needs A, B, C, D resource. This is what we call a workload specification. I've worked on the SCORE project, so I'm picking this. We're denoting this to the CNCF now. You can take other options. There are other options also on this tooling landscape, but they're all the same and they're all open source, so it doesn't really matter. Here we have a this is what the developers would use as code. It's in next to the service source code. If we think back of this here, it's essentially what is in the application source code. You have one of these files for every single microservice, service, however you cut this, and it will describe the relationship. So, hey, I'm a product service. I need a Postgres S3 and DNS. It's super simple to learn. We're regularly doing stress tests. Developers learn that in less than 20 minutes. Very, very easy. This is your golden path. Should you need another resource, all you add are 2 lines here. The rest will be taken care of by platform orchestration. Should you need a new environment, a PR environment, send this, indicate a new context. Context is PR, you'll get a new environment. All of this thing is now possible due to this element. And then you have an orchestrator. And the job of the orchestrator, as I said, is to dynamically generate app and infrastructure configurations every deployment and keep the drift between the rules, the configuration, and the actual running infrastructure to absolutely zero with every deployment. The deployment is the pulse of this. So the deployment is the pulse of your platform. Now, abstract request goes through CI, sits post, the orchestrator sits post CI, gets them deployment metadata, reads the rules. My workload should be observed by Datadog. When environment type staging, I need the Postgres definition too. If a new DNS is requested, I need Cloudflare. And now actually recompiles everything, builds this, policy checks this, and off we go. And now here we go. We have the golden paths now. If you need a new S3 bucket, you don't need to wait. You don't need to go through reviews. Security doesn't give a shit. Nobody cares. You add 2 lines of code to your workload specification. Everything else is matched in the background and enforced globally. Spin up a new environment. We've been there. Just git push, new context, everything else dynamically created. You need to upgrade your version 14 to 15 of your Postgres instances. No problem. Update one file. All the workloads that depend on that definition will be updating with the next deployment. There are security measurements to make this in a secure way, but it's straightforward. Now, you also have a very clear way of actually auditing stuff because everything is created with every single deployment. It's absolutely logic. You can run a diff between deployments to know what's happened. We can now dream about things like replacing Datadog for all the non-prod environments because it's so expensive with Prometheus and Grafana. All is there now. Now, I want you to think about the implications. This will have, and this already has, on the ground, in the enterprise right now, this isn't science fiction, extreme implications. In this model, you are 50% more efficient in your operations group. And this has political implications. You are going to, it's going to change the landscape. These things work tremendously, but obviously change the job profile. You have a certain, this is something that the organization has to get used to. But that said, how do you approach this now? And the simple answer is you start very, 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 very small. You do not promise anything to anybody. You do not, this is not my glasses, but they look exactly the same. Fantastic. So you do not go out with a big bang. You do not assume that you can get all of this done in a short period of time. This will not work. You essentially take your pioneering application that is on the lowest common tech denominator, your 80-20 approach, and you will build a platform that is 10 times better than what you have right now if you want following this design paradigm. And then you are going to make this first team into believers. You need to be priest-like and make these people love this because it's so great. Spend an outlier amount of money on making the first experience perfect. Don't overpromise, always overdeliver, and pitch your managers that if it's amazing at a small scale, you are in a situation where developers are going to demand to be on the platform. And only if your users are going to demand to be on that platform will you be able to sell them on this, and you will be able to actually get them excited about going there. And so that is my warm recommendation. And those reference architectures, check them out, learn from it. If I'm totally fine if you don't want to buy anything, I don't care, but take this as an inspiration how amazing looks like. Because one of the big problems in platform engineering is that many teams are building or want to build a platform, and it's like building an iPhone, and the group of people that is trying to build the iPhone have never used a phone, and that is non-trivial. All right, 44, just in time. Are there any questions?
Just in time, Casper. Thank you. Okay, we have the first question. In the reference architecture, the diagram depicts the security plane at the base secrets and identity management, but for multi-cloud security and identity trust are really difficult and painful. For cloud identity federation is mentioned. Can you speak to the challenge of interconnecting cloud container systems and containers in multi-cloud?
Yes, we didn't cover this today. We should do a wider one in more detail on this. But this is something. Yeah, this is a big topic. So you will probably need, and that's why there was this gateway. You'll probably need a gateway set up. You need to make sure you have identity federation between those different clouds. That's a whole topic, but with this abstract setup also possible, because you can essentially pass on the identity that the workload is supposed to resume, depending on what estate it's currently running in. So the solution there is a combination of gateway and identity federation. That's actually a fantastic topic. We should do a whole session on this.
Thank you, Tom, for suggesting another topic for the webinar. I'll get the note. Cool. While you guys type in other questions, just wanted to mention that I shared the reference architectures that Casper mentioned in the chat, so you can check them out over there. Also, the webinar with Cortex, the link to the webinar is in the chat as well, but it's not tomorrow, it's on Thursday. So you can check it out over there. And yeah, if you have any questions, type in faster. Yes, and we got the question. Are there any golden paths for how the internals of platform orchestrator should work?
Are there any, sorry, can you repeat this, please?
Are there any golden paths for how the internals for the platform orchestrator should work? Like, I guess, characteristics.
Yeah, okay, yeah. So the orchestrator should essentially follow this read, match, create, deploy pattern. That's essentially the orchestrator is a responsive system, right? It's responding to the rhythm of the platform. That means, and the rhythm of the platform is the deployment. So as the deployment comes in, the orchestrator should respond with always consistently the same pattern, which is an RMCD pattern: read, match, create, deploy. In the read phase, it should read the abstract request, plain and simple, and it should always, assume day zero. So a platform orchestrator doesn't care about the past, doesn't care about the future, is like a true Berlin hipster, always living in the moment. So that means read phase, just read the stuff. Then in the match phase, the orchestrator has to be able to identify the context. And that's where you want the orchestrator to read in deployment metadata. Get that from your CI pipeline in the build, at the end of the build process, send the tag or whatever identifier you want to use to tell the orchestration system where you're going. You want the orchestration system to know, this is the app ID, here is the env ID, this is the environment type that we're targeting. Then in the matching phase, we are taking this context and we are matching this with the rules. So now we want to identify the right rules provided by the platform group. And this is essentially a sorting mechanism And the sorting mechanism helps us to identify the right resource definition based on the context. So let's say you have a long list of all the resource definitions that describe all the ways to configure all the resources across all environments. Then the first sorting mechanism we use is to say, okay, this abstract request is, I need a database of type Postgres, return all resource definitions, filter all resource definitions where type equals Postgres. Right, then we have a list of, let's say, 10 different resource definitions. Next, please go ahead and further filter this list down based on the matching criteria context. So now give me where Postgres equals staging and, where type equals Postgres and context equals staging. Now, based on those two, I have a uniquely identified resource definition. Otherwise, I have to add further attributes, and then I have the right resource definition to actually execute. Now I'm saying, okay, perfect. Read match phase done. I get into the create phase. In the create phase, I'm taking the default configurations for that, and I'm executing them using a driver system against the actual cloud. And I'm saying, okay, no matter what changed under the hood while I wasn't there, this is a new deployment. I'm going to enforce the status quo. The orchestrator is always the source of truth. And I'm going to then forward input into, this could be just a Terraform module, to enforce the exact state of the configured resources. And then I'm getting to the deploy phase. In the deploy phase, we are deploying the image, and we are then going to inject the secrets at runtime. So the orchestrator has created or updated all the different resources, and in return, the orchestrator receives the credentials from the clouds to say, like, okay, DB name, DB user for the Postgres, S3 is, what do they always have, like host, region, take all of this, and now through the secrets management system, inject these things to make sure that the final deployment is running. So read phase, match phase, create phase, deploy phase. That's how an orchestration system works.
Sometimes, Casper, you sing a song, no? RMCI.
Yeah, exactly. RMCD.
RCD. Next question. In the whole integration and delivery plane based on containers, is the whole integration and delivery plane based on containers? If yes, does this mean that the platform engineering team should ensure that the application code is containerized and then stored in ECR and passed to the orchestrator?
Fantastic question. This is really only because this is what I'm usually focusing on. No, no, this is really just a example choice. You could just as well design this for VM, although for VM it's really difficult because VM has such a variance in operating system. You can do this for Lambda, you can do this for serverless. This is just a choice that I took. Yeah, because I mean, that's what I meant, right? You will probably, like, reasonably, internally you're only going to be able to deal with one delivery plane, integration delivery plane, because that's where most of the complexity lies. You can visualize whatever in a user interface, but the integration delivery plane is non-trivial. My base assumption is always, as a team, you'll be able to do this well for one compute type. And so I like to focus on containerized systems, but again, that's only preference.
Makes sense. If you have hundreds of applications, the underlying Terraform can be very slow. Do you recommend making separate state files for each application?
The underlying Terraform is only slow if it's very densely packed, right? If you have a Terraform file that does everything, like these incredibly complex landing zones, then this is slow. But the trick is that you have to modularize. And that means you want to have modular components for each part. And this is where we're getting into the interesting stuff. The reality is, if a developer says, I need a Postgres, it doesn't mean they need a, I mean, in most cases, it doesn't mean they need a plain Postgres. It means they need a service user, they need a VPC, an instance, whatever. But the trick is, you want to build those building blocks modular. One for the VPC, one for the service user, one for the Postgres itself. And then the thing is, and this is where good platform orchestrators are so important, good platform orchestrators are able to execute resource graphs. And a resource graph is a nested dependency of modular recipes. So a resource graph would essentially read all of those things and say, oh, this Postgres actually needs a service account. And then it would first go to build in a cyclic resource graph. First do the first one, get the output from that resource execution, and use it as the input for the next one. And that's the solution to slow files. Like, you shouldn't have big files because they are impractical to maintain, and they're insecure and just not efficient.
Nice. If the company is using ServiceNow for Service Catalog, would there be any reason to use Backstage instead of ServiceNow Catalog?
I don't think so. I mean, I think ServiceNow Catalog is totally fine. Yeah, like, if possible, stay on that.
Good. There was a question around whether or not we have reference architectures for Azure, and the one that you showed is for AWS. So I shared the link to the reference architectures on Azure, but if you want to give a brief update when the code one's coming out, Kasper.
Yeah, so we owe you that. I'm aware, and we're getting that. At this point, I'm getting this question 3 times a day. So the answer is, we do not have that prioritized just yet at the moment. If you really need this, reach out to us. We can set this up for you. It's not that we don't have it, like, we have it, but it's not in a way where our CTO would say, oh yeah, this is great, because if you look at this, it's ready for open sourcing yet. Because, if we put things out open source, we want to make sure that this follows our policies and we can put our name behind it, and people don't look at this and say, oh my God, what are you doing? But if you want, we can give you that already. It will just not, it's just not open source. Yeah, so if you're interested, just reach out to really anybody at Humanitech, and we will help you set that up.
Nice. Do you have a reference architecture for not containers setup where more cloud native services are used?
So the reference architectures support many different services. So for instance, any database, any file search, any DNS. The only thing that they're optimized are that the workloads, so the actual services, are running inside containers. So that doesn't mean that the Postgres is running in container. The Postgres can perfectly well be Cloud SQL or RDS or Azure DB. That's fine. So that's not the problem. But we are at the moment, just from a product engineering perspective, really focusing on containerized systems for the workload again. Any other resources possible.
Cool. And I guess last question: can all the activities across the planes be visible using a backlog management tool like Jira?
No, but Jira has put out a new product called Compass. And I know not everybody likes Jira products for whatever reason. They are like, everybody bashes them. But I think this is a fantastic product. If you're in the Jira world, I would absolutely use Compass and not anything else, because you will have beautiful integration with all other systems, and it's very clean. And I think the team has done a fantastic job, and it's very low integration, and it's a great product for the money you're paying, which isn't much, and like definitely Compass. But yeah, Jira can't do it really. I mean, you can probably bend it with the APIs, but it's difficult.
Cool. And we're on time. No questions. Really, really cool on timing this time. And you received so many compliments, Casper, in the chat. So
That's flattering. Thank you very much. Yeah, this is only possible because of all of you. And thank you very much for your interest in what we're doing. And this thing that we're all very passionate about. I encourage you to be active in the communities, to share your failure stories. We need a lot more of people coming up and saying, hey, this didn't work, this didn't work. We need a community of people that across the globe share the things that didn't work. This is still early on in the platform engineering journey. So thank you very much for being on this journey with us and letting us serve you, and looking forward to the next sessions.
Yeah, and to wrap it up, you can submit your topic right here. I'm sharing the form, or just go to the platformengineering.org, and there is like little banner at the top, submit your talk, or hit me up in the Platform Engineering Slack, and I'll be happy to set it up for you, and looking forward to have more practitioners, platform stories at our sessions. Thank you very much for joining. We'll send over the webinar replay and slides to everyone tomorrow, and hope everyone has a safe and amazing end of the week.
Thank you, Maria.